This video is on powers of complex numbers in polar form. So on the next slide, we're going to be using a formula. So we've already worked with multiplying two vectors together in polar form. So if you remember, we did the product. So if you multiply two vectors together, you multiply r squared, 2 times theta, 2 times theta. The pattern continues if you now have z squared times z, and you would have now 3 theta r cubed. You continue it again, z cubed times z. Notice you're going to have now r to the 4th, 4 theta, 4 theta. So there is a pattern forming there, and we're going to be using the theorem on the next slide to help us when we have powers of complex numbers. All right, so here's our DeMoivre's theorem, where we want to multiply by I power of n. So whatever that power of n is, maybe it's power 5, power of 6, this would be our formula we would use. So here's our example 7. We want to find out what is this complex number as a power of 6. So multiplying it 6 times. So we're going to use our formula. So I'm going to go ahead and write the formula down. Z sub n equals the quantity r, quantity cosine of theta plus I sine of theta, raising it to the nth power, this case is going to be a power of 6, equals the radius raised to the power of n, quantity cosine of n theta plus I sine of n theta. All right, so let's go ahead and do this question. So notice our power is 6. So if we say z to the 6th power, that's going to be our n. Our number 2 here is our radius. So we're going to say radius of 2 raised to the 6th power. Quantity cosine of n, remember n again is 6, and now we identify our theta. This is our theta, 20 degrees, our angle. So we substitute in our I sine, and then 6 theta. Now we need to simplify it. Alrighty, so 2 to the 6th power is 64. Quantity cosine, 6 times 20 degrees is 120 degrees. Plus I sine 6 times 120 degrees, or 20 degrees, 120 degrees. So if we were to leave it in that form, that would be considered polar form. But it is asking us to write our answer in rectangular form. Rectangular form is in the form a plus bi. So to convert it to rectangular form, we need to use our unit circle. So think about here's our coordinate plane. Here's about 120 degrees. And then we have this radius sitting out here. radius in out here. Okay, what is that ordered pair on our unit circle? That is -1/2 positive square root of 3 over 2. Just like from unit 4, this represents our cosine of 120 degrees, and 3 square roots of 2 is our sine of 120 degrees. So we're going to go ahead and substitute those values in. So z to the 6th equals 64 cosine of 120 degrees is -1/2 plus the sine of 120 degrees is square root of 3 over 2. So z sub 6, or raised to the 6th power, is 64. Substitute in the cosine of 120 degrees, which is -1/2, plus I, the sine of 120 degrees is square root of 3 over 2. Then we need to distribute that 64 into both terms. That's -64 divided by 2 plus 64I square roots of 3 over 2. And then we simplify those fractions. -64 divided by 2 is -32 plus 32I square roots of 3. This answer is now in rectangular form. So what did we find? We found that complex number raised to the 6th power is now this new complex number in rectangular form.